So for today's lesson, I'm going to take an approach that's a little bit different than the last one. Today's lesson, we're going to take a look at absolute value problems where we're going to have a graphical solution with number lines involved. And the whole idea here is that I want to bring you into the next idea of a deviation. And the concept of deviation is this. Imagine if you're a manufacturer. And in manufacturing, you need to make ping pong balls. Okay? So you're manufacturing ping pong balls, and the general diameter of a ping pong ball is, let's say, hypothetically 1.5 inches. Is that about right? Maybe 1 inch, actually. Maybe a little more. Let's say 1 inch for now. And when making these ping pong balls, you know as a manufacturer, they're not all going to be perfect. Some are going to be a little bit off, some are going to be a little bit different, but you have some allowable room for error. And that allowable room for error is what you call a deviation. It means that it could be 1 inch, but it could be up to like 1.001, or it could be as low as 0.999 inches. But anything like 0.7 inches, that's off. It's way off, right? Compared to an inch. Or 1.5 inches is way more than an inch. So you have what's called a deviation or an error that's allowable. In this section, in 2.5, this is a method that honestly, when I was in high school, my teacher never taught this, because my teacher was all about math. Like just pure math and no applications. And I saw this section in your textbook, and at first I was like, skip it, I never learned this when I was a kid, it's not needed. But it's actually really useful. This whole concept, the mathematical, like the problem solving concept will really help you a lot in a physics course or an engineering, ideas that you're going to learn here. So I do teach this topic, although it is a little bit different of an approach than the previous section. In the previous section, 2.4, we took what's called an algebraic approach. This is going to be what's called a graphical approach. So the different means to the same result. Okay, so let's take a look first. First, we've thought of absolute value, right, in the previous lessons as distance between a given coordinate and 0 on the number line. The distance between a given coordinate and 0. Now, if we look at the next statement, we could say that the difference or the distance between numbers a and b is simply absolute value of a minus b or b minus a. And for a moment, think about this. It doesn't really matter what a and b are. Let's make a 7. Let's make b 4. What's the distance between them, everybody? 3. Now, if I subtract them the other way, what is it going to be? Negative 3. So if I put absolute value around it, it's the same thing. That's obvious, right? 7 minus 4 is 3, or the absolute value of 4 minus 7 is still 3. So the absolute value of a minus b is the same thing as the absolute value of b minus a. That's the first thing we want to start to think about. Let's go right into the example from that. So this is going to be a graphical approach. Solve this algebraic first. Algebraically, from the last lesson, solve this first. We're going to prove it's the same thing in a moment. So go ahead and practice using the same method you used on your homework over the weekend, trying to solve this algebraically first. So just split it into the two parts. We'll solve each of them separately. I want you to do it algebraically so we can prove it graphically in a moment. What do you get for your two answers? What do you get, Tristan? -1 and 7? +1 and +7? +1, +7. Check your answer with the 1 there, Tristan, okay? Pretty sure the answer should be +1 or +7. Those should be your answers, 1 or 7. Check the work. All right, we'll try to find a mistake right now. All right, now, keep that in mind, okay? 1 and 7, keep that in mind. Look at the numbers in the actual absolute value. Look at the numbers in the absolute value. See if you can figure out where those numbers 1 and 7 come from. It's not obvious, so if you can figure it out, that's awesome. It's not obvious at all. And I'm going to show where it comes from in a moment, but try to figure out on your own. I'll give you a minute. Figure out where the numbers 1 and 7 come from that equation. And if you have a good number sense, you might be able to pick up on it in a couple seconds. Maybe it'll take you like 30 seconds or so. Figure out where they came from those numbers alone without doing any sort of algebraic manipulation. What do you got, Rich?
Would it be like even the 4 and the 3 mixed
You see that right away? Some of you saw, I saw a few hands go up right away. That was good. Okay, 4 plus 3 is 7, 4 minus 3 is 1. So there's some connection between those numbers and the answer itself. So what we're going to see in this class, or in this section specifically, is that we could think of this as deviation again. We could think as deviation. So this means that the distance between x and 4 is 3. Let's write that down. The distance between x and 4 is 3. That's what that statement says physically. Again, the distance between x and 4 is 3. This comes from the previous slide. On the previous slide, we said absolute value of a minus b is the distance between them, right? That's what we said in the previous slide, right there in blue. Absolute value of a minus b is really defined as the distance between those. So in this case, again, we could say the distance between x and 4 is 3. That's what that statement is saying. So what could x be? 7 or 1? Again, start at 4. Start at 4. Everybody, think about the number 4 in your mind. Go 3 units below, you get to 1. Go 3 units above, you get to 7. That's all this is doing. It's a different approach to this, but the concept is that you're starting somewhere and you're deviating from that value. That's all you're doing. So this value is like your starting point. And this we consider like our deviation. So if I was solving this graphically, I start with my starting point of 4, and I simply deviate 3 above and 3 below. That's all that's happening with this approach. It's actually, I think, easier in the algebraic approach, but it becomes a little bit difficult when the problem gets a little bit more complicated than the one we're seeing here. This is kind of like an introductory problem. The approach seems easy because, again, the numbers are relatively easy and relatively straightforward. It's when they get a little more complicated that it gets difficult. What's important right now is that you guys understand that absolute value of a difference simply means the distance between those values. Again, absolute value of a difference, not a sum, but a difference, means the distance between those two values. Let's take a look at the second one to apply this a little bit further. But do you all see how the answer is the same, whether it's algebraic or graphically approached? The answer is still 1 or 7. That's what your answer is, 1 or 7. Now how about this one? It looks very similar to the last one, but now we don't have an equal sign. Now we don't have an equal sign. But you know what I want you to do? Make believe it's an equal sign first. Solve this graphically. Do not use algebra for now, please. Go right to a number line. Draw your number line. Think about your starting point, what your starting point should be. Draw yourself a number line. Figure out your starting point. Figure out how much you should deviate by, above or below that starting point. And forget that it's less than or equal to. Just treat it as an equality for now. Did you choose A or B? How many of you picked A as your answer? How many of you picked B as your answer? How many of you have no idea why you picked A or B right now? Okay. Let's go over this for a sec. This is where it gets a little confusing. Remember in the previous slide, or the previous two slides, we said that the difference between two numbers is defined as the distance here, if we're looking at absolute value. Do we have a difference in this problem? What do we have? We have a sum, right? So what do I have to start by doing? Y plus 3. What can I write that as? Yeah, y minus negative 3 is really what I have to think of. So the first thing you have to do is rewrite the setup like this. Okay? Again, The distance between 2 points is actually the difference here. The difference, not the sum. So your starting point is going to be -3 in this case. Okay, your starting point is going to be -3, not 3. So we start at -3, and we deviate 5 above and 5 below. 5 above is the story. 5 above would be -3 plus 5 is 2. 5 below would be -3 minus 5 is -8. So this is the same approach we took to the previous problem, but now it's not an equality, it's an inequality. Do I shade between the numbers, on the outside? What do I do? How do I know? How do I know where to shade here? Because this is clearly an inequality, so there's going to be shading involved. It's not going to be an equality. I know that because it's less than or equal to, I can at least put a closed circle for now on both spots. I know that for sure. Because it's not less than or greater than, it's an equal, less than or equal to, or greater than or equal to. So I know those are closed circles. So I am.
Yeah, I was going to say, like, it's going to, both of them are going to go in that way.
No? There's 2 ways to answer this problem. There's 2 ways to figure out the answer to this problem. Think back to lesson 2.4. In lesson 2.4, when we saw that something was less than, we automatically assumed it was an and statement. And when it was greater than, we assumed it was an or statement. Now, if you don't like to memorize, then don't. That's fine. You don't have to memorize that. I'll give you another way to figure it out. Pick a number. Pick a number in one of those 3 regions. Think about these points as separating the graph into 3 regions. Here's region 1. Here's region 2. Here's region 3. Pick a number in region 1, number 2, or number 3, and test that number in the original statement. You're going to see this when you get to calculus. This is number line testing. You're going to use a good amount in calculus class. So either pick a number over here, or over here. It doesn't matter what number you choose. Try it on your own, please. Try a number that is less than -8. So try a number like -10 in the original. If you put -10 in the original, is it true or is it false? Is it true or is it false? It's false, Bridge? Ash, agree? Others? False or true if you try -10? Yeah, it's definitely false, right? -10 plus 3 is going to give you -7, whose absolute value is 7, and 7 is not less than or equal to 5. So if you try a number out here, you're going to get a false answer. Or you get a false statement, I guess we should say. How about a number in between? What's the easiest number to try in that middle region? Please, make it easy. Oh, easier. I guess that works too. But generally, what's the easiest number to try? 0 is usually easiest because it doesn't affect anything. But yeah, I see why you said -3. If you try -3, these cancel, right? And you get 0 is less than or equal to 5, which is true. I would have tried 0 naturally just because 0 is always easy to try, but it doesn't matter. If you test 0, you get 0 plus 3 is 3. Is 3 less than or equal to 5? Sure it is. So this region here is true. And then on the other side, Tristan, if you try the number 4, right, out here, try the number 4, because it's in this region, plug it in. Is it true or false? Yeah, it's also false. Very good. And we know that's false because simply 4 plus 3 is 7. 7 is not less than or equal to 5. So it turns out that the middle region is the only region that is true. A true statement means it's part of the solution set. Our answer will be this. Or, in interval notation, this. Okay, either way it can be represented. The first one is in solution set form. The second one is in interval notation. The concept here, though, is the same, really, as what we did in the first example. Again, this was your starting point. This was your deviation. You start at -3, deviate 5 up, deviate 5 below, you get your endpoints. Once you have these endpoints, test region 1, region 2, region 3, you get your solution. Or recognize that a less than or equal to in this arrangement means and is shading in between. If this were a greater than or equal to, we would have shaded out here and out here. It would have just switched the answer solution up. Question? You had a hand? I thought you put your hand up for a second. Again, so if we had switched this to a greater than or equal to, we would have sure shaded out here and out here. It would have been an or statement in the end. Okay? Does this make sense, this line from the number line? Are there questions? Please ask if there are. Are there questions from here to here? Is it obvious that this shaded region gives you this solution right here? Okay, it means from -8 all the way through to 2, including those endpoints. Including those endpoints.
I just read that.
Yeah. So again, just to give you a statement. This here means from -8 all the way to 2, including all those values and the endpoints. Okay, and the endpoints. That's what this is saying, and this is saying it also. Remember, this is called solution set form, and this is called interval. Solution set interval. It's the same answer, right? It's the same expression. You're just giving it two different ways. There's a tendency, I don't know why this is. I would love to look this up or figure out why textbooks do this. When you're younger, for some reason, there's a tendency for answers to be given in solution set form. But then when you get to like calculus and pre-calc, everything's in interval form. So personally, I think it's the same. It makes no difference to me. It's easier to write in interval form because it's condensed. See how it's condensed? It's much easier to write it that way. So it makes sense to do that later on when you have a lot going on and you're solving one calculus problem and it takes you like 2 pages to solve. It's good to have it this way because it's more condensed. So maybe that's why. Why they don't use this from the beginning on, I don't know. I mean, I get that that solution set form is useful also, but they're interchangeable in this case. Maybe Mr. Linus would know that actually. He teaches pre-calc and calc. He probably would know that for some reason. It's like a random fact. But I could ask him. We'll see. It doesn't really matter right now. Let's go ahead and take a look at this example. Now, with this example, it's even trickier. And you need to stop and ask yourself for a moment the form in which it's written. It is absolutely not in the correct form to start. You need to manipulate the original before you can go anywhere. So try to figure out on your own real quick, what should you make this look like? And go back to the last example if you need to. Go back to the previous example and take a look at what's going on. Try to make this one look like the beginning of their last one. And it's not easy. There's 2 things you need to do. Not just one, but 2 things you need to do. Take a minute to do so. Okay, take a minute to do so. Max picked up on both. There's 2 things you have to do here, not just one. 2 things. If you're struggling right now, I'm going to put a hint on the top right. Okay, that's from the first slide of the day. We talked about this. Okay, those 2 things are identical. Again, try numbers. It works no matter what you do. The absolute value of b minus a is the same thing as the absolute value of a minus b. So that enables you to do something automatically to this inequality. What could you do first? What's the first thing, George?
You could move it that way 2r minus 7.
Yeah, that's the first thing I would do for sure. You can absolutely do this. I didn't mean that as a pun. You can definitely do this. Absolute value of 2r minus 7 is greater than 5. You can do this for sure. That's the first step, though. You have to do one more thing still. You had the first part. Let me give somebody else a chance. Max got both right. I know that. What do you got, Luke?
Divide by 2.
Yeah. We want that r to be by itself. If you remember that this value needs to be alone here. This 2 is going to throw us off. So let's take a 2 out front. Let's take a 2 out front. When I do that, it leaves an r minus 3.5 greater than 5. Okay? Again, how do I know it's 3.5? What's half of 7? 3.5. And if I distribute this back out, I get back to what happened. Okay? So earlier I mentioned like don't distribute it into an absolute value, yet you're undistributing here, or you're factoring it out. You can do that. It's not against it. It's like the greatest common factor. Okay? So my suggestion here would be this. When you have a problem like this, the variable needs to have a unity coefficient, a 1. If it doesn't, divide by whatever that is. If this was a 5, divide by 5, divide by 5.
Don't you have to divide on the other side?
No, because I'm not dividing, I'm just taking it out front. Right? It's still here. You're right. If I divided everything by 2, I can do that also. That actually works fine. I can divide everything by 2, which actually is what I'm going to do now. Okay? Yeah, the next step, Tristan already kind of jumped ahead, was, hey, how do I get rid of this 2 now? Divide by 2 on both sides. And this is the arrangement we're going to use to graph. So go ahead and graph this here. Okay, so yes, you could divide everything by 2, absolutely. Go ahead. Once you get to this, it's easy, right? Notice that? That's what I was saying earlier. If you can get it to look like this every time, variable minus some number in the absolute value, either greater than or less than or equal to some number, it's easy to do. It's getting into that form that can be a little bit complex at times. Annette, help me out. What's my starting point?
Your starting point is 3.5.
Good. And how much am I deviating by?
2.5.
Which brings me to what?
Plus 2.5 is 6, minus 2.5 is 1.
Good, very good. Now, Bridge, tell me, please, what's the deal? Am I going to shade in between these open circles or outside of the open circles? And if you don't know, what should you do, actually?
If I don't know?
Yeah, if you didn't know whether to shade in between the circles, right? Do I shade in here or do I shade out here?
And or statement.
You want to know if it's an and or an or statement.
So in this one, because would it be you shade in between the 2 circles?
What's your reasoning, though, I'm asking?
Because it's greater than 2.5. Actually, I don't know.
Let me go over with you then real quick. Hold on one sec. If I see this bridge as my starting point, and it says that the deviation should be more than 2.5. This is 2, this is 2.1, this is 2.2, this is 3, this is a deviation of 7, this is a deviation of 10.
Oh, okay.
So we want it to be more than 2.5. So I want it to be here. Or I want it to be
they go
here.
in opposite directions.
Yeah, now if you didn't know that by reading this, just test the points. Remember I did that in the last problem? That's why I said, what would you do? So try a point in each region if you need to test it. Tristan.
I was wondering, how did you know, how do you know it's like not negative 3.5? Because for the other one it was negative, right?
Because if you recall, remember this is, whatever this number is your starting point. As long as it's written in the form variable minus starting point.
Okay.
And in the previous one it was x or y minus negative 3, wasn't it?
Oh, so the starting point is negative because there's 2. Oh, that makes
Because
sense.
it was a negative value. But this is, remember, this is not what you're looking at. That's done. That's what you're looking at right there.
Okay, that makes
And in the previous one, if you covered this up, you still had a negative 3. That's why. Okay? Now, again, though, I'm glad that Bridge kind of, asked that question there about which way. If you want to see it visually, just to visualize this, okay? So in case you want to see this, instead of testing, this means the distance between these 2 points is greater than 2.5. Well, here it is. 2.5 would be exactly here. A distance greater than that would be out here, or out here, or out here. But the distance between here and here is less than 2.5. That's a distance of only like maybe 1.5. And then from here to here is a distance of 2. And then 2.5. And then 3. And then 4. And then 5. So these are the points that are going to be in the answer. So I'm going to shade out there. Same thing's going to happen over here. So we definitely have an or statement here because it's going in opposite directions. Again, if you didn't know that off the top of your head by looking at this problem, test points. Where do you test points usually? Where do you test points? Or should you test points?
In each section.
So give me a point in a section to test.
1.5.
All right, so a point in here you would test. Let's not use decimals. It's messy. All right, well, 1 is the endpoint.
So then 2.
2, thank you. So in this region, let's try 2. Let's go back to the original. Try 2 in the original. 7 minus 4, absolute value. Is 4 greater than 5? Is 4 greater than 5? No, it sure isn't. So when I test 2, the answer I get is false, isn't it? And remember, we're shading in true statements, not false statements. How about a number out here? What number would you choose in this region? It's not appearing, it's delayed, sorry. What would I choose? 0, absolutely. Choose 0, please. Try 0 in the original. 7 minus 0, is that greater than 5? Absolutely. 7 is greater than 5. And then again, you would try another point out here. Okay, something out there. Say a number like 8. 7 minus 8 is actually, what was the original? If I try 8, 7 minus 16 would give me negative 9. And then I have to worry about, okay, what this absolute value. So 9 is greater than 5. That is true. So true.
Well, don't you know that it's going to be an and statement from the original thing?
Very good. So you can recognize things along the way also. Again, the trial of points is just for you to check it if you want, okay? No, that's fine. That's good. That's a good statement. That's absolutely right. Okay, if you could recognize that this region works, then most likely this region is going to work also, right? Because it's an or statement. I get or statement in this case, an or statement. So what was our answer? What would it look like if I wrote this? I need to write an answer still. That's just a number line. How do I write the actual answer, Max?
You do R in solution set.
Either one, whichever you'd like.
R is greater than 6 or R is less than 1.
Very good. In interval? In interval? Somebody else? In interval? George?
6 semicolon 1 semicolon.
This is a little trickier. Kate?
So that little parentheses, negative infinity, comma, 1, parentheses, or parentheses 6, comma, infinity.
Very good, Kate. And Kate recognized to switch the order. Although Max gave it as r greater than 6 or r less than 1, which is totally correct. If you're writing in an interval notation, you have to look from lower to greater. And here's how you do it. In case you're wondering what just happened with interval, watch what I'm going to point to, please. Out here. Oh, come on. It's not showing up now. Come on. All right. Look at my iPad as I'm pointing, please. Out here. Oh, there we go. We have negative infinity. And it's a true statement all the way up until where? Positive 1, right? So that's my solution for that part right there. Then, see this gap right here where it's false? That gap is really like the or in a sense, okay? Then it starts up again from 6 all the way to where? Infinity. That's this part right here. Make sense, George? Okay. Because your answer was a little bit off. That's why I want to make sure you get it. Now, another way to write the middle part, instead of the word or, is this symbol, if some of you have seen it. And that simply means the union of two sets. That's all it means. Okay, it's another way to write or. And in interval notation, you should use that symbol, actually. This means or, if you want to replace that in your mind for interval notation. The other way, by the way, means and. The other way means and. Okay, you're not going to see that with these because with an and statement, we write it as a simple interval set from like 1 to 6.
Would you accept it if you wrote or though?
Yeah, it's fine. They're interchangeable. And honestly, at this point, I want to see that you can answer an interval notation, but you can give an answer either way. Keeping in mind, though, that on a multiple choice, the answer choices may be all in interval, or they may be all in solution set. So you have to be able to manipulate between the two, or change your answer between the two. Okay, or understand how they can be perceived differently. There is, listen quick, there's one more example. It's a really interesting example. I might just lead off with it tomorrow, or you could at least look at it tonight. It's on the next slide. And then there's homework. Okay, make sure you get to the homework on the next slide after that, please.